This is a little quiz, 14 pages of questions. Pause the video to have a go in your own time, then you can see my answer. They're not necessarily, they are quite aimed to be quite difficult, but they're not necessarily difficult per se, but they are kind of inventive, and I've tried to make them so they'll make you think a bit and maybe deepen your understanding of maths. Okay, let's have a go. Describe each of these as percentage change. That would be 50% decrease, or you might have said 50% of the original. This would be a 2% increase. This would be a 0.5% decrease. This one, oh, did you get an answer for this one? I'm going to say that's a 100% decrease, which means you got nothing left. What about this? Right. Ooh, as neatly as I can, I'm just going to start trying to make things look the same. So I'm going to make those two numbers look the same. So that's 2 to the half to the n equals 2 to the x divided by 2. I'm just going to write 3y straight away because I can see that that's what it would have been, 2 cubed to the y, but then you multiply together the 3 and the y. And in fact, why don't we do the same over here to save time? We'll call that n over 2. Okay, so then that's 2 to the n over 2 equals, I'm going to combine these, x minus 3y. Oh, well obviously this and this must be the same for the equal sign to be true. So n over 2 equals x minus 3y. I'm going to times both sides by 2, n equals 2 times x minus, oops, that's supposed to be an x, 3y. There we go. I think that's as neat as it will go. Well, not very neat writing, but neat in terms of letters used and stuff. Have a go at this. 7 squared. 7 to the minus 1. 7 to the half. What about that one? That's 7 to the 1. And that's 7 to the 0. What's the remainder of quotient here? Haha. I like this question. So many students can't do it because, hey, we kind of forget how to do this, don't we? I've even got a piece of paper to the side of the computer to remind me, if I'm honest. Right, so we do long division like this, and it's like, oh, I can fit 3 of them in. So 2 times 3 is 6. So I'm going to take that away, and that'll leave me with 1. So I can now say that the remainder is equal to 1, because there's 1 left over, and the quotient is 3. Because, let's just write down here, the question might have been worded differently. 2 over 7 is 3 remainder 1. Okay, next. What about this? Well, I'm just going to expand out this. It's a sum from n equals 0 to 1, so it's 0 times k plus 1 times k. Should we just write that as k equals 100? It said solve. By the way, that disappears, yeah? Oh, so that just means k equals 100. Done it. True or false? n cubed plus 1 is odd. Implies that n is even, implying in both directions. I'm going to be a bit creative in how I answer this. I don't know a very systematic way that always works, as in which side to do first and stuff like that. Anyway, I'm going to start with this side, and I'm going to say, what if n is even? Well, in that case, I've got even cubed plus 1, which is even plus 1, because if I cube an even number, it's still even, which becomes odd. And what if n is odd? Remember, I'm working from the left-hand side here. I'm ignoring the right-hand side at the moment. Well, then I've got odd cubed plus 1. Well, if you cube an odd number, it's still odd. If you're not sure about that, think an odd number times an odd number is odd. And then you times an odd number by another odd number is still odd, which is even. Okay. So in this direction is true, because if it's odd, then n has to be even. And in this direction it's true, because we know that if n is even, n plus 1 cubed is odd. So therefore, true. Next. I kind of like this question just because it catches a few people out. Make sure you divide both sides by 3, which I'm going to do, well, let's do it 2 ways. So you can make it look like that, or I'm going to make it look like this by separating out the fractions 2 bits, which I can do because that's like this is being divided and then this is being divided. I couldn't have done it if it was the other way around. There were two things at the bottom. Yeah, I know that that could be simpler, but I don't care because I'm not looking for that. I'm only looking for this. So the gradient equals 2/3. Next. I like this question. So you may or may not be doing some like functiony stuff. I'm going to pretend I don't really know how to do this. I'm going to say, well, I recognise it's a function. Oh, how do you find an inverse? Well, okay, well, I start with x, and then I times it by 2, and then I minus 1, and then I divide by 3. So I guess if I wanted to go in the other direction, I'd have to times by 3, then plus 1, and then divide by 2. So that would be going in the inverse direction. So then that means that f to the minus 1 of x, because I happen to remember how to write that, is going to be 3x, because I have to times it by that first, then I have to add 1, then I have to divide by 2. Now there's an alternative approach, which is you can go, well, I'm going to write y equals 2x minus 1, and this is often the standard approach that most students know and they think it's the only way, and arguably it is the only way anyway, just because it's so easy. I'm going to add 1 to both sides, so 3y plus 1 equals 2x, and I'm going to divide both sides by 2, which means that 3y plus 1 divided by 2 equals x, and then that means I can write, oh look, I'll just confirm the answer a different way. Let's have a go at the next question. Answer is proportional to volume. I like to throw this in just to check that you know. Mass depends on how much of something there is, so it's proportional to the volume. That can be important with the way some questions are worded. True or false? Right, we've got two objects added together. What's an elephant plus an elephant? 2 elephants. What's an x to the half plus an x to the half? 2x to the half. Well, that's not the same as x, is it? So it's false. I also like to throw this question in. The answer is minus 9. This is controversial. I've had students get very angry, actually get quite angry about this, saying that they're definitely right. Now, what is true is minus 3 squared is 9, because that would be minus 3 times minus 3. But remember BIDMAS, or however you describe it, indices are the second thing, and only later do we do subtraction. So that minus sign just sits there, and remember when we do indices it's acting on the thing directly to the left, and that's it. One way I explain it, which some students find useful, is imagine there's a 0 in front, because otherwise what's the minus sign doing there? I don't know, some people find that confusing. Anyway, there we go. Next question. Yeah, another question I'd like to just throw in because I think it's useful. A prime number by definition is greater than 1. I always try and remember this just because it's kind of important. Because you just need to remember the arbitrary definition of what a prime number is. What about this one? Minus 3. What have I done? I have applied, I've times by minus 1 on the top. Is that how I've done it? I've taken the minus sign out of here and put it outside, which means I've had to switch the sign of what's inside. So they now cancel, so the answer is minus 3 over x minus 2. Last question. Okay, I'm going to write that as 1/5 times 3 over 2, which then becomes 3 over 10. I'm going to write that as 1/5 times 1 over 7, which is 1 over 35. I'm going to write that as 1/5 times 10 over 1, because I'm a bit paranoid like that, I just want to be careful. So that's 10 over 5, which is 2. That's 1/5 times, I don't want to times that by a decimal, I'm going to convert that to a fraction, which is 1 over 20. Hopefully that was useful. Good luck with your maths.